Hey everybody, remember this? Last time we met we were doing section 4.4 on working with the laws of logarithms. We had four properties, product law, a quotient law, and a power law, and a change of base. These five examples, some of which we covered before, are related to the first three of those laws, the product, quotient, and power laws. I know we did a few of these in class before, but it wouldn't hurt to go back over them. This time I'll go through all five in order, and that'll make it a little easier to follow in your notes. So, example 1a, it says expand as a sum. We have a natural log of qx, and that means q times x, right? In algebra, when two letters are multiplied together and next to each other, we assume they're multiplied unless we have a symbol in between indicating they're added or subtracted. So that's a product, and the product law says we turn a product of logarithm of a product into two logarithms, one of each factor of the product, and add them together. So that's the expanded sum in letter A. In letter B, we're doing the opposite because we're given a sum, like the answer to this, and asked to turn it back into, or condense it, shrink it down into a single log, from two logs back to one. So in part B, we're actually using the product law in reverse, taking the sum of these two logarithms and then saying, well, a sum is equal to a logarithm of a product, so this sum is the logarithm of its product, 0.01 multiplied by 1,000. So we're putting the times in to make it the product side of the expression. 0.01 multiplied by 1,000, I believe is just 10. So this is log of 10, if you want to continue to simplify it somewhat. And remember, log without a base means base 10. So this is log base 10 of 10, which is asking us 10 to what power equals 10. And as we've seen in some of our special logarithm rules, that's log base b of any number that's the same number, b, is always equal to 1. 10 to the 1 makes 10. So this is actually equal to 1. You could also check that on your calculator using your LOG button, add those two logarithms together and see if you get the answer 1. In part C, we are expanding, so we're using the law sort of in the forward direction instead of backwards like we did in B. This one's a quotient, a fraction of two numbers, and therefore we use the quotient property, which changes one logarithm into two that are subtracted. In this case, I don't think we can simplify because I don't know what power of 2 makes 76 or what power of 2 makes 13, so we'll just leave the answer in that form. For part D, when we condense, we are taking a subtraction and turning it back into a quotient, except in this case it's two natural logarithms being subtracted, and that makes one single natural logarithm of the quotient 54 over 6. 54 over 6 is the same as 9, so you could write natural log of 9 and then stop there, or if you want a decimal answer, you could put that in your calculator. The final one is a power. It doesn't have a product or a quotient, but there's x to a power, so that power 4 would be the c in the product law that comes down in front when you apply the law. The law is the logarithm of a to the c equals c logarithm of a. So this would be the number 4 in front of the same logarithm, but just of the x. So the 4 ends up in front of the log instead of in the power. So those are some applications both forward and backward for the first 4 examples of the product quotient laws, and then just one use of the power law.